Welcome to Chapter 9, Fundamentals of Research. So, in this chapter, we're going to talk about the basic elements of research design, such as like hypotheses, specifically hypotheses of association versus difference. We're going to talk about different group designs, variables, things of that nature. And the reason that you will need to know all of this information is because when we get to the final exam, you're going to have to read hypotheses and know which statistical test to run. This chapter is going to give you a lot of information on what clues to pull out from those hypotheses to be able to identify the correct statistical test. Okay, so there are two broad types of hypotheses of difference and hypotheses of association. So with hypotheses of difference, we need to do an experimental design in order to test that hypothesis. Whereas with a hypothesis of association, we can do a non-experimental design or what's called a correlational study. Okay, so let's look closer at experimental research, which is defined as a deliberate manipulation of a variable to see if corresponding changes in behavior result, allowing the determination of cause and effect relationships. So those words, manipulation and cause and effect, are popping out at us because they're really the defining features of experimental research. We don't have manipulation in correlational research or non-experimental research, as it's sometimes referred to. And as you know, with correlation, we certainly cannot determine cause and effect relationships. Whereas with experimental research, we are able to do that because of that manipulation, which is the change that the experimenter deliberately produces in a situation. So the manipulation is referring to the independent variable, and we're manipulating the independent variable because we think that that is the variable that's causing the behavior to change or to exist, while we're holding all the other variables constant and unchanging. So in other words, with experimental research, we have a lot of control because we're able to kind of guess what the extraneous variables might be, which variables might affect our DV other than the one we're interested in studying. And then once we've identified what those variables may be, like with the violent TV causes aggression example, perhaps what causes aggression besides violent TV would be things like domestic violence at home or high levels of testosterone, or if a person is on a substance like bath salts. Any of these things might lead to someone being more aggressive, but we're not interested in that. We're interested in, does violent TV cause people to be aggressive? So we would need to control for all of those other extraneous variables, and we could do that by making sure that everyone in the class, everyone in the study does not come from a home where there's domestic violence. We could test them for high levels of testosterone, etc. And so we would make all the participants as similar as possible so that the only difference that we could see in their behavior would be due to the independent variable that we're studying and not some other factor that we're not aware of. So because we're doing the manipulation and we have that control over our study, we're able to say that the only thing that's causing the effect would be our independent variable. And so therefore we're able to discuss or determine cause and effect relationships with experimental research. Okay, so if you are going to do experimental research, you would want to start by identifying your variables. So let's first remind ourselves what a variable is. And a variable is anything that can be measured and varies in some way. So it's a lot of things, especially when we're studying people. This could be behaviors, events, or other characteristics that change within that person or vary between people or animals. So you'll have to figure out which is the IV, and that's going to be the variable that you want to manipulate, the variable that you think causes the change in the behavior. So for example, if I was interested in what causes the change in aggressive behavior between people, so why are some people more aggressive than other people, then I might have my independent variable be violent TV, because that might be the one that I think causes the change in the behavior of aggressive acts. So then I would also need to decide which variable I'm going to measure in that situation. And here, as we just discussed, we have decided that we're going to measure aggression. So that's going to be the dependent variable. It's what we're measuring. It's the effect and the cause and effect relationship. It's the effect on the behavior because of the manipulation. So I personally always feel like it's easier to identify the dependent variable than the independent variable, because I just think of the dependent variable as being where the numbers come from. So if the numbers are number of aggressive acts, then I know that aggressive acts is my dependent variable. Also, I like to think of it as the dependent variable is called the dependent variable because the numbers that we get on the dependent variable depend on what goes on with the independent variable. So if you are in the violent TV group, we would expect to see more aggressive acts using this hypothesis. And so if you're going to do aggressive acts or not depends on if you were in that violent TV group. It's also important to point out that with independent variables, they can have multiple levels or conditions. So, for example, if we wanted to use our independent variable of violent TV, we might be interested in looking at specifically what types of violent TV cause aggressive behavior. So maybe we would have like action movies, westerns, and psychological thrillers. And so then we would say that the IV violent TV actually has three levels or three conditions because we've broken it down more specifically into those three types of violent TV programs. And then also you need to know that there are constants, and constants are those variables that we consider early on, the extraneous variables, and we want to hold those constant. We want to keep them the same across all of our participants so that we can be sure that the only variable affecting our DV is our IV. All right, so the next thing that we're going to talk about is the levels of measurement. And when we're looking at levels of measurement, this is really specifically referring to the dependent variable. So at what level of measurement, and your options are nominal, ordinal, interval, and ratio, are you measuring that dependent variable? So we're going to break down what these different types are, but you need to know which type of dependent variable data you're collecting so that you can determine which statistical test you should use. Because, for example, like chi-square uses nominal, and Spearman R, which you'll learn later, uses ordinal. Pearson R uses interval. So the level of measurement that you're using will determine what test you use in part. So nominal data is also called categorical variables or frequency counting, nose counting data. And basically what I ask my students to think of is nominal meaning names or words. So if the participant gives us the data in the form of a word, then we know that we have nominal data. So if we were to ask participants what's your eye color, and participant A says blue, participant B says brown, participant C says green, they're giving us the data in the form of words, so that is nominal. Now, as you know in statistics, all data, regardless of how it's collected, eventually has to be turned into numbers so that we can run those numbers through our formulas and do math on them. Because you can't do math on words. So sometimes what we will see is researchers working smarter, not harder. And so they might just put down on their clipboard that they're using to take measurements, for example, or their Excel spreadsheet. It is 2020. But they might just put down on their clipboard blue eyes, brown eyes, green eyes, and then when they go up to participant A and participant A says blue eyes, they just do a tally on the blue eye column, and then they go to the next participant, they say brown eyes, they do a tally there. Next participant also says brown eyes, do another tally there. And then you count the number of people that said brown eyes or blue eyes, and that's how you are converting those words into numbers. But sometimes when we're reading our hypotheses on our homeworks and our quizzes and stuff, nominal data can be among the hardest to spot because it will talk about the data in the form of numbers after the fact. So we always want to make sure that we're checking what did the participants give to the researcher. Did the participants use words? Did the participants use numbers? Okay, so then we also have ordinal data, and ordinal data is rank ordered data, so like first place, second place, third place. I like to remember it as ordinal because you're putting things in order. We might ask people to do that in a research design. So, for example, I might ask people to rank order their favorite classes, and then I might give them a list of options. So, like history, art, psychology, rank order your favorite. And people put one, of course, psychology is number one, history number two, philosophy is number three, or whatever. But what's important to note about ordinal data is that we say that it is not equal interval data because the intervals between the values are not necessarily equal. So if someone runs a race and the person that comes in first place runs it in 10 minutes, the person that came in second place runs it in 11 minutes, and the person that came in third place runs it in 30 minutes. So the difference between first and second place is 1 minute, and the difference between first and third place is like 20 minutes. So the intervals between the values are not equal. Maybe you like your psychology class the best, and then history is a close second, but philosophy is a distant third. So if you're looking at a hypothesis or a research design, and you see that word rank or ranking or any derivative of that, order, generally that's a good indication that you're working with ordinal data. Next, we have interval data. And with interval data, different than ordinal data, interval data, the intervals between the value are actually equal. So interval data is most identifiable by the fact that it is collected in numbers. So ratio data is also collected in numbers, but there is a difference between the two. And with interval data, the data has an arbitrary zero, which just means that numbers can go negative. They can go below zero. Whereas with ratio data, the numbers cannot go below zero. There's an absolute zero. So for interval data, you would have temperature being able to go below zero. So temperature would be interval. You would have my bank account being able to go below zero. So my bank account would be interval. And then you have things like height for ratio, where a person cannot be below 0 feet and 0 inches tall. So there we have an absolute zero. In this class, we generally just kind of combine interval and ratio because all the statistical tests that we use for data collected in numbers are going to be applicable to interval or ratio data. But I just want you to know for future statistics classes that you may take that there is a difference, and it has to do with there being an arbitrary zero for interval and an absolute zero for ratio. But any data collected in numbers is going to be interval ratio data. So when you're looking at hypotheses and research designs, you can look for keywords like numbers, scores, ratings, not rankings, but ratings, like on a scale of 1 to 5, how happy are you? And let's say you give that a 5, that's a rating, but that is a number, so it would be interval ratio. And again, you have to be careful because nominal data, while it's collected in words, it's converted pretty quickly to numbers. And so sometimes nominal data will discuss the number of people that reported they had brown eyes. And so that word number can pop out at you and you can think it's interval when it's not. So be careful with that. But generally, any measure that refers to a number or is collected in the form of numbers is going to be interval ratio. Okay, so then in an experiment, we do have groups, and that is another keyword to look for when you're looking at those hypotheses and research designs. If you see the word groups, then generally we are discussing a hypothesis of difference, because a hypothesis of difference, which is what we test when we do an experiment, is literally looking for the difference between groups or conditions. And so whenever you're reading that research design or hypothesis, if there's any mention of multiple groups and conditions, it's a very good clue that you are testing a hypothesis of difference instead of association. So anyways, with the experiment, the two groups break down into the experimental group, which is the group that receives the treatment. So they receive the manipulation or the change. We do something to the experimental group. And then you have the control group, which do not receive a treatment, or they might get a placebo or something. But basically, they act as a baseline for comparison against the data on the DV we get from the experimental group. So we can actually have multiple experimental and control groups. Again, we discussed that if you wanted to have people watch violent TV, you could have multiple levels of the IV violent TV with the horror, the Western, and the action movies. And so you could break that down into three groups where the first group watches the horror, the second group watches the Western, and the third group watches the psychological thriller, action, whatever I said, I can't remember. But, anyways, so you can break down that experimental group into multiple groups, and then you can compare the DVs between those groups, and you can also compare the DVs within the groups. So let's look more specifically at the different types of group designs. And here I have a little note that you could think of the design as referring to how we're measuring the DV or when we're measuring the DV. So we can measure the DV after we've given out the IV, we can measure the DV before and after we've given out the IV, or we could do kind of a mix of both. So that's what we're discussing here. And we'll start with the between groups design. So here we're referring to measuring the DV between the two groups, or however many groups there are. So there's two ways to do a between group design. You can give the IV, and then you can give the IV to the experimental group and not to the control group, and then you can measure the DV in both groups and compare them. Or you could do what's called a repeated measures design. It's also called a pre-test, post-test. It's also called a before and after design. But in this case, what you are doing is you are giving the IV to the people in the experimental group, but you're measuring the DV before you give the IV and after you give the IV. So you're repeating that measurement twice. That's why it's called repeated measures, or pre and post test, because you are measuring before you give the IV and after, or pre the IV and post the IV. So with a within subjects design, the measurement here is looking at comparing people within the same group. So if I wanted to compare those scores on aggression just within people that watched the violent TV, so just within people that were in the experimental group, I could do that. Generally, when we do a within subjects design, we need to compare their scores before and after the IV, because otherwise we won't have a basis of comparison, since you're not comparing them to another set of people or another set of scores. So in other words, if I wanted to do my violent TV and causing aggression hypothesis with a within group, I would need to measure their aggression levels, then give them the violent TV, then measure their aggression levels again. And then finally, we have a matched or paired subjects design, and this is kind of a mashup of everything that we've talked about, or a mixed model. And so with a matched or paired subjects design, one of the things that makes it different is that you're going to find someone in the control group that is matched on a characteristic with someone in the experimental group. So let's say that with our violent TV and aggressive behavior hypothesis, what we're interested in doing is also studying the effects of age on aggression. So then we could match someone in our experimental group that's 5 years old with someone in our control group that's 5 years old. And we can continue to do that. So someone that's 10 years old in our experimental group and someone that's 10 years old in our control group. So it always helps me to understand matched or paired subjects if I keep in mind the fact that statistically we treat a pair or a matched set of participants or subjects as one, statistically, as one person. So that helps me to remember that a matched or paired subjects design is the within portion of the design of this kind of mashup of between and within designs happening at once. So the within portion would be that age, because we're treating those two people as if they're one when we do the statistics. So you could think of it like that now. They're one set of people representing 5-year-olds if they're both 5, or they're one set of people representing 10-year-olds if they're both 10. And then what that allows us to do is compare the effect of violent TV on aggression levels, but also isolate the effect of age on aggression levels. So we're comparing 5-year-olds to 10-year-olds to 15-year-olds or whatever, and how aggressive they were. So we're comparing within the ages. But we're also comparing between the groups, because we're still comparing the effects of violent TV on aggression. And so we still are looking at the difference in aggression levels between the group that watches violent TV and the group that doesn't watch the violent TV. So you can do these type of matched designs or paired subjects designs using an after only design, which is good to use, especially if you're worried that your hypothesis might get revealed doing a pre-test, post-test. Like if you were to measure people's aggression levels by asking them questions on a survey about aggression, and then have them watch violent TV, and then give them a survey again, or measure their aggressive acts after watching the violent TV. This might give away that aggression is the measure that you're looking to study, and so this might alter their behavior consciously or unconsciously. They might become more aggressive or less aggressive than they naturally would be had they not figured out our hypothesis. So, whether or not the hypothesis would be revealed is one of the main things that you should consider as a researcher when choosing between an after only design or a before and after design. But ultimately, because this matched or paired subjects designs includes the between group and the within group, you're able to do the after only design or the before and after design, just depending on your hypothesis and which one's appropriate. Okay, so I have a few final bits of information that you'll need for the multiple choice and short answer section of the quiz and the final. So for this slide, we're going to talk about the importance of randomization. And we remember that randomization involves, first of all, selecting participants from a population into your sample. And we've discussed different sampling methods to do that systematically. But after you have selected people at random to be in your study, then they need to be randomly assigned to one of your groups. So we're still talking about experimentation here. So the groups would be your experimental groups and your control group. And in order to get people randomly assigned to either of those groups, you could flip a coin, you could draw names from a hat, you could pull straws, any way to randomize who gets in what group, because it would not be appropriate for you to, as the researcher, for you to select who gets to go in what group, because you might engage in some bias there. Consciously or unconsciously, we all, of course, want our hypotheses to be supported, and so we might unknowingly, or if we're shady, knowingly, put people into the experimental group that we think are going to demonstrate the behavior we're looking to find. So there's shady ways to do group assignment, but random assignment kind of avoids any of that. So then random assignment really gives researchers an equal chance that participants will be comparable across experimental groups or conditions, and that all characteristics would be represented kind of equally in between the groups, so in the experimental group and the control group. Okay, now we're going to discuss experimental hazards. And so there's three major effects that we're going to talk about today. And we're also going to talk about ways to kind of manage those effects or circumvent them or prevent them. So the first thing that we're going to talk about is the placebo effect. And just as a reminder, a placebo is a false treatment. The purpose of a placebo is to hide the purpose of the study. So, for example, if you are a medical company that's developed a drug to treat the coronavirus or the cold or whatever, then you might have people come down to your lab that have the illness that you're looking to treat with your cold medicine or the medicine you've produced. And so you take the people and you randomly assign them to the experimental group or the control group, and then the experimental group would get the actual medication that your company has made, and the control group might get a placebo, like a Skittle with the coating shaved off, for example. But one of the things that can happen when you administer placebos is that people can kind of figure out what's going on and then think that they have been given a treatment, and the mind, being a powerful thing that it is, will then change their behavior, or it can even cause them to have a reduction in the symptoms of the illness or whatever, just because they think they've been given the real treatment. So that would happen maybe if they came down to the lab and noticed that everyone that was sitting there was coughing and sneezing and looked sick, and then everyone's handed this pill, and you also are sick. So you might just conclude that you've been given some pill to treat your sickness, and then you get better because of the placebo effect. So one of the things that you can do to try to avoid the placebo effect is known as a single blind procedure, and you can also do a double blind procedure. A single blind procedure, though, is when participants don't know if they are in the experimental or control group. So you might let them know that there's going to be half of the people getting a real medication and half of the people getting a placebo, and let them know that they're not going to know which group they're in. And then you could also do a double-blind procedure, which is where the participant doesn't know if they're in the experimental group or the control group, and also the researcher doesn't know if the participant's in the experimental group or the control group. So maybe I would get an assistant, if I was the researcher, to come hand out the pills and write down who's in which group. But I don't get to know who's in which group until after the data has all been analyzed, and then I can look back and kind of figure out where people were. So, doing a double blind procedure like that is actually also very effective at curbing what we call experimental bias. So, especially the experimenter effect, which is a type of experimental bias. So sometimes if researchers are kind of there in the lab administering the treatment, they might say or do things unconsciously that influence the participants' behavior. So I don't know, maybe when they're handing out the pills, they're saying, "Oh, this is really going to make you feel better," but when they're handing out the placebos, they're not saying anything, for example. So experimenter effects can be avoided by doing those double-blind procedures. Okay, another effect that I actually don't have on this slide is called the observer effect. And this is where sometimes participants will try to guess what the experimenter wants and then give them that behavior. So they'll either just pretend to have a reduction in symptoms or pretend to be more aggressive than they actually are because they think that they're helping us with the experiment when really they're not helping us. Or there might be other motivations to do the observer effect. That they might even be unconscious. They might not even realize that they're doing it. And then there's the Hawthorne effect. And so the Hawthorne effect I've seen referred to as many things, but it's basically the tendency of people to behave differently as a function of knowing that they're being watched or observed. And so this is problematic because rather than getting their true behavior that we would get if they didn't know that they were being observed or they didn't know which behaviors we were seeking to measure, then we would get a more realistic look at that behavior. But when people engage in the observer effect or the Hawthorne effect, it ends up hurting our study and decreasing the validity of it because they're not behaving as they would if they weren't being watched. Okay, so we've talked about extraneous variables before, but just to clarify what they are, an extraneous variable is a variable that may affect the outcome of the study, but was not manipulated by the researcher. So an extraneous variable could potentially have an effect on the DV, but we don't want it to have an effect on the DV because the only thing we want to have an effect on the DV is our independent variable, our IV. So extraneous variables are variables that may end up creeping their way into your study if you don't control for them. And if they do creep their way into your study because you didn't control for them, then at that point we would kind of level them up and call them a confounding variable. So a confounding variable is when an extraneous variable does affect the outcome of the study. So let's say that you identified a bunch of extraneous variables that could affect your dependent variable of aggression besides violent TB. And so, what could affect aggression besides violent TB? And you have a list of things like domestic violence, warrior gene, bath salts, high levels of testosterone. And so, you do what you can to hold those variables constant. You control for them with randomization. You control for them by doing pre-screening and making sure that people that come from homes with domestic violence are not in the study, or whatever it is that you do to control for your extraneous variables. But let's say that you missed one. There was someone outside handing out giant pixie sticks to your participants, and they were all hopped up on sugar, and you had no idea. Well, now sugar would be called your confounding variable because it did work its way into your study, and it did possibly have an effect on that DV of aggressive acts. Okay, so when we have a significant outcome, that is really all that we're allowed to say about our outcome, that there is a significant difference between our groups. We're not allowed to say the word prove, and the reason that we can't say the word prove is because of individual difference. So while we do everything to make the people in our groups as similar as possible, they all come from homes without domestic violence. None of them have the warrior gene. They all have the same IQ. They all have the same socioeconomic status. The only thing that is different is whether or not they watched violent TV. And so if one group is more aggressive than the other group, and that group is the group that watched violent TV, they're the same on all other accounts, so it must be the violent TV that's making them do this behavior. So that's kind of the basis for the theory in which we work off of. However, the fact is that people are not identical. People are not the same, and we don't always know what's going on inside their heads either. So while we're showing them violent TV and then they're acting more aggressive, it's not necessarily because of the violent TV. They could have been, looking at my face the whole time, and my face, for some reason, made them really mad. Maybe it reminded them of the fifth grade playground bully, and they just were getting furiouser and furiouser as they were kind of remembering these times when they were being bullied or whatever. So that could have been the reason that they were getting frustrated and more aggressive, and it had nothing to do with the fact that they were watching violent TV. So, for reasons of individual difference, we're not able to say that we've proven anything. Also, we haven't tested everyone in the population, so we can't say that we've proven anything either. So, what we are allowed to say is that there is a significant difference between our groups, and it's important to point out that the difference isn't just a difference, but that it is significant. So, group one doesn't have 12 aggressive acts, the experimental group doesn't have 12 aggressive acts, and then the control group has 11 aggressive acts, and we're like, we did it, we supported our hypothesis. But the difference between those groups would have to be significant. So the experimental group would need to have like 20 aggressive acts, and the control group would need to have like 0 aggressive acts. But that's why we do statistics to determine what those thresholds are that would allow us to support our hypothesis. And those thresholds are like being 95% confident or being 99% confident. And so the probability that we're wrong in supporting our hypothesis is less than 0.05 or less than 0.01. So we always want to achieve external and internal validity as researchers. So external validity is when we are able to generalize our findings to other populations or settings. If our findings only hold true with our sample or our population, then we wouldn't say that we have external validity. So you may have heard of the study where researchers found that when people are speaking, if they look up and to the left, generally they are lying. That study did happen, and those researchers did report those findings. However, when other researchers tried to replicate that study, they were not able to get the same findings. So we, as researchers, conclude in a scenario like that study must have lacked external validity. Maybe the original researchers did their statistics wrong, or there was something unique about their population that wasn't considered as an extraneous variable. But nonetheless, not being able to replicate a study and find the same findings in different samples or in different populations is an indication that you are lacking external validity. So then there's internal validity, and this refers to the validity of the measures within our study. So did we do our study correctly? Did we control for all of our extraneous variables? Was it our IV that really caused the change in our DV? And if we can say yes to that, then it's likely that we do have internal validity. So if the researcher controls for extraneous variables, then there should be more internal validity within the experiment. So we need to make sure that we understand that for the exam. So now we're switching gears a little bit, and we are going to talk about non-experimental research, which can also be thought of as post facto research, which is Latin for after the fact. In this case, referring to after the IV's already been administered or has already happened naturally. So, to do a non experimental research, we generally use correlational designs or correlational studies. And with correlational studies, we're just measuring the relationship between two variables. So, we're interested in seeing as variable x increases or decreases, what does variable y do? Does it also increase or does it decrease? So, does it go in the same direction as the other variable, or does it go in an opposite direction as the other variable? We're also able to determine from correlational research the strength of the relationship between the two variables. So you can think of that as when one variable increases, how often does the other variable increase? Is it 100% of the time, 80% of the time? So we're able to determine that with correlational research. And correlational research tests the hypothesis of association. So that word relationships is a key word in any derivative of it. So relation, any synonym of it, association, correlation. All of that would be indicators that you are testing a hypothesis of association. So, in addition to identifying hypothesis of association by the word relationships, it can also be identified by the lack of multiple groups. There's not going to be multiple groups. There might be one sample or one group that's being asked questions about behaviors they've already done. For example, maybe they are people who use drugs, they're addicts, and obviously it would be unethical for us to give them drugs in an experimental group and then not give other people drugs and measure some behavior as a result of those drugs. So, since we really can't do that, what we could do is have people come down to our lab and ask them questions about their drug use and maybe their personality. And so we could see, for example, if there's any type of relationship between being an extrovert and drug use. However, we would not be able to conclude that extroversion causes drug use, even if we did find a significant relationship. All we would be able to tell from that research is as drug use increased, we also saw that there was an increase in reporting of extroversion characteristics or whatever. But that could just be coincidental, or there could be something going on there. If there was a relationship going on there that researchers felt was interesting, then they could kind of just proceed into doing a full experiment so that they could account for all of the other variables that might increase drug use besides just extroversion, if that was one of them. And another thing that you can look for as a defining feature of correlational research or hypotheses of association is that the variables are always assigned. Well, the independent variable is always assigned. So because this is post facto research, it's happening after the IV has already occurred, or the treatment, the manipulation. In the example I just gave, the person's already taken the drugs. We're not giving them the drugs. So because this is happening after the fact, they are already coming down to our lab having the characteristic that we're interested in studying. So this is considered an assigned variable. They're being assigned to our study because they have the characteristic. And so when we're doing correlational research, we're always using assigned independent variables. All right, so now we're going to practice with everything we've learned in this lecture. We're going to get our research methodology worksheet from our course on Canvas, and then we will go through and pull out the clues to let us know what type of data we have, variables, hypotheses, etc. Okay, so here we have the research methodology worksheet, and what we're going to do is go through each of these experimental designs, isolate the hypothesis, determine if it's a hypothesis of difference, and we remember when we're looking for a hypothesis of difference, keywords to look for are going to be groups, conditions, whereas with association, we're just hypothesizing a relationship between two variables. So in a hypothesis of association, you just have one sample that you're testing. There are no groups. You might have one group, but that's just your sample of people. So our keywords for association are going to be relationship and any variation of relationship, same with correlation, association. So then we're also going to be identifying the level of measurement. We remember nominal is for names and categories, ordinal is for rankings, and interval ratio are for numbers. So let's get started. Number 1 says an instructor investigates the relationship between the number of minutes needed to complete an exam and the score on the examination. So the first thing that I have highlighted here and pulled out is this word relationship. So the word relationship lets me know that this is looking at a hypothesis of association. This word problem or this experimental design does not mention groups at any point, so I'm going to assume this is an association. And then as for the level of measurement, I'm going to say that this is an interval ratio, DV, and the reason for that is because of this word here, number of minutes. So because I'm measuring my DV in number of minutes and also score on the examination, I know that tests on exams are scored with numbers, and then obviously the word number there, number of minutes, would indicate to me that that's an interval scale. And then for number 2, the experimental design says a researcher wishes to find out whether there is a difference. So difference is going to be another key word for hypotheses of difference, obviously, and any variation, so differ. So in addition to groups, we have just the word difference, but let's check out this hypothesis further. So it says a researcher wishes to find out whether there is a difference in IQ between men and women. So here this problem has us pulling out the IVs, and we remember an IV is an independent variable. It's the variable that's being manipulated. In the cause and effect relationship, the IV would be the cause. So if I'm looking here at this hypothesis, which is to see if there is a difference in IQ between men and women, if I isolate that hypothesis, I could say that what I am measuring here is going to be IQ. So that's going to constitute my DV, because DV stands for dependent variable. In the cause and effect relationship, the DV would be the effect. And so here we are measuring IQ scores. So I'm going to write that down for my DV. And now back to the IV. As we had mentioned, the IV is the independent variable, the cause, the manipulation. And so here we have our manipulation, or our treatment, so to speak, as being men and women. So gender is going to be our IV. And then we would have to indicate if our gender is assigned or manipulated. So again, we remember that assigned independent variables mean that the participants are coming to our study already having the characteristics that we are looking to investigate. So we are not able to manipulate someone's gender. So when someone comes to our study, we're not able to go, you know what, we're real short on men today, so we're going to need you, this female person, to be a man today. So we can't manipulate gender, but we can mark it as assigned, because people come down to our study already having their gender. We don't manipulate that. And then also the dependent variable is IQ scores. So we need to indicate if the IQ scores are nominal, ordinal, or interval, because our level of measurement pertains to our DV. So scores would be collected in the form of numbers. So this is going to be interval. And then as we pointed out earlier, I just forgot to check it, because of that word difference, and also because I do have these two groups, group 1 and group 2, men and women, I'm going to call that a hypothesis of difference. So for number 3, we have a researcher wishes to test the hypothesis that fluoride reduces dental cavities. A large random sample of college students is selected and divided into 2 groups. So groups is going to be a key word here. Groups is going to be a key word for the hypothesis of difference. Okay. One group is given a year's supply of toothpaste containing fluoride, while the other group is given a year's supply of seemingly identical toothpaste without fluoride. A year later, all subjects are checked by dentists to establish the incidence of caries or cavities. And so the data is collected in the number of cavities a person has. So if we are to go through this, the first thing that we can do is isolate the hypothesis. So the hypothesis is that fluoride reduces dental cavities or caries. And so we already have determined that we have a hypothesis of difference, and we know that one reason is that we want that we have these groups here that we want to compare and see the difference between. So that's kind of our major clue, it looks like. And so now we're going to break down our IVs and our DVs within this hypothesis. So we're looking at the hypothesis that fluoride reduces dental cavities, and we know that we're measuring our data in the number of cavities. So if we're looking for our IV and our DV, we're going to say that our DV is the measurement, and we know that the data is being collected in the number of cavities. So that is going to be our DV, number of categories. And then if we were to ask ourselves what level of measurement is that DV at, we would have to go with interval because, again, of that word number. So number is the giveaway here that we have an interval scale. And then finally, we have to identify the independent variable and determine if it's assigned or manipulated. So it looks like what we have done with these two groups is one group got toothpaste containing fluoride, whereas another group got a seemingly identical toothpaste without fluoride. So I would say that the independent variables here are going to be that fluoride, because that's the thing that we are manipulating. So I think I spelled fluoride wrong. Oh well. And then these two should be switched. Okay, you know what? I'm just gonna erase it. I can't. My OCD won't let me do it. Okay. Fluoride, what a weird way to spell it. And there's two levels of that. So we have toothpaste with fluoride and toothpaste without fluoride. So toothpaste with and without fluoride, I will say. And again, the U goes first. Some weird style of writing. Okay, so the fluoride has its two levels. So it has one group gets the toothpaste with the fluoride and one group gets the toothpaste without the fluoride. And so we have to ask ourselves if that is assigned or manipulated. And so if a variable is assigned, it means they come down to our study already containing the variable we're looking to investigate. So would people come down to our study being perfectly divided into two groups and just happen to have toothpaste with fluoride in their pocket, and then the other group just happened to have toothpaste without fluoride in their pocket, and it all just happened naturally and we just got so lucky? No, that's not possible. We are going to have to split the groups into two and manipulate who gets the toothpaste with the fluoride or without. So this variable is going to be manipulated. And then for number 4, we have a researcher wishes, we're not going to do the confounding. A researcher wishes to establish that special training in physical coordination increases reading ability. So a group of 40 10-year-old children is randomly selected. Each child is given a standardized reading achievement test and then placed in a specially designed program of physical coordination and training. After 6 months of training, the reading achievement test is administered again. The scores show significant improvement. So that word scores is just jumping out to me. And so that's going to indicate to me that the data is being collected in the form of numbers. So I am going to assume that this is an interval ratio dependent variable. And so since I know that scores are interval ratio, well, what are the scores on? And the scores are on the children's reading achievement test. So the DV is going to be scores on the reading achievement test. So then we have to ask ourselves, well, what is the IV? So again, it is always nice, I think, as just a habit to get into, to go ahead and isolate that hypothesis. Sometimes those keywords just jump right out at me and I gotta mark them, but we should always be isolating our hypothesis. And then here we go, establish that special training in physical coordination increases reading ability. So we've already accounted for the reading ability being our DV here, because we know that that is what's being measured by the scores. So through process of elimination, that just leaves physical coordination as our independent variable. So physical coordination. Okay, so what we need to determine is if physical coordination is something that they are coming down to our lab already having, or if we're putting them into some type of program. And it looks that we are putting them into a program, so that's a manipulation that we are making. And it looks like all we have left here is a hypothesis of difference or association. So this one is a little confusing here because it says a group of 40-year-old children is randomly selected. Each child gets a test and then placed in a physical coordination training program, and then they're given that same test again. So while there is only one group of children here, they're not being divided into two groups, they actually are constituting two groups, because this is a pre-test, post-test design where they're being given a test, and then they're being given the IV, and then they're being given the DV again. So test, physical coordination training, test again. So this is a pre-test, post-test, or it's also known as a before and after. It's also known as a repeated measures test. And so what's going on here is that there actually are still two groups. You have the group when they take the exam the first time, then they're going to be given the IV of the training program, and then they're going to take the exam again. So here what we actually have are two conditions that we're going to look to see if there is a difference between as a function of the IV. So we're going to say that this is a hypothesis of difference because our two groups are the pre-group and the post-group. Okay, so here we have page 2. And page 2 says, a researcher wishes to assess the possibility that a certain type of psychotherapy actually reduces neurotic symptoms. So I'm going to go ahead and just isolate that hypothesis now. So the possibility that a certain type of psychotherapy actually reduces neurotic symptoms. Okay, cool. So that's the hypothesis. So let's see how they tested that hypothesis. A random sample of subjects is selected from the population of names on a waiting list at a mental health clinic. Just FYI, we don't call people subjects anymore. We call them participants. This is just an old worksheet. But anyways, for each participant selected, another participant is sought, also from the waiting list, who resembles the originally selected participant, in a number of important respects, such as age, length of time on the waiting list, IQ, severity of symptoms, length of symptom duration, category of neurosis, and previous treatment history. By a flip of a coin, one group. Okay, one group. Let's keep that in mind. One group is chosen to receive 6 months of therapy, while the other group is told to wait and not seek treatment elsewhere. That doesn't sound ethical. At the end of the 6-month period, a panel of experts judges all the subjects with respect to the extent of the symptomatology, assume some type of quantitative assessment. So quantitative is another word that's jumping out at me because quantitative means numbers. So I know that we're measuring, it looks like the symptoms, with some type of quantitative or numerical assessment. Okay, so those are kind of my main clues here. So let's go back to this hypothesis and get the IV. So this says a type of psychotherapy actually reduces neurotic symptoms. And then I know that we had talked about how some people were going to get the therapy and some people weren't. So it sounds like that's the manipulation, the psychotherapy, kind of who's told to go get therapy and who is told to not. And so that is, in this study, it looks like that is not being assigned. In other words, they're not coming down to the study with half of them already being in therapy and half of them not, although that probably would be the ethical way to do it. But instead, in this study, what they're doing is finding people and telling half of them to get therapy and the other half to not. So they're manipulating, the researchers are manipulating who gets the therapy and who doesn't. Okay, so then it says, back to the hypothesis, that they are predicting therapy to reduce neurotic symptoms. And I also know that they're going to be measuring those symptoms with a number-based system. So I'm going to then assume that the symptoms are going to be my DV, and that those are being measured with an interval ratio scale, because that was already discussed here. And then the hypothesis is going to be the hypothesis of difference. And the reason for that, oh, I did spell symptoms wrong. Darn it. It's really bugging me. Okay, symptoms. Barely talk. I just kept looking at symptoms. Anyways, hypothesis of difference. There's multiple groups, right? And so looks like we finished that one. Let's look at number 6. A consumer research group asked 100 men to use each of 3 kinds of aftershave lotion for 1 month. After the trial period, each man indicated the lotion he preferred. So the data was collected in the number of men who preferred each lotion. Now this one is a little bit tricky because immediately this word number is popping out to me and that has me thinking it's interval, but it's not. So these clues are pretty reliable for the most part, but not always. So you have to be careful. So let me explain to you why this is not interval. So back to the hypothesis here. Well, actually, it doesn't look like there's any hypothesis, right? It's more of they just want to know which method is preferred, but it doesn't look like they're making a prediction. So with that in mind, it looks like there are 3 kinds of lotion, and they want to know how many men preferred each lotion. So in this case, the lotion is going to be the IV, and that is manipulated because the researchers are giving the people the different types of lotion. And then the DV is going to be preference because it's the number of men who preferred each lotion. So you have to imagine that the men are getting 3 types of lotion. This is how I draw lotion, I guess. Looks like a soft drink. Okay, and this one's Johnson & Johnson, this one's Aveeno, and this one is, I don't know what else is there out there. Target brand, Up and Up lotion. Okay, so you have these 3 kinds of lotion, and then you ask the men, which one do you prefer the most? And they say, Up and Up, and another man says Aveeno, and another man says Up and Up, and another man says Johnson & Johnson. And so what they're giving us in terms of data is words. And so words are going to be nominal. And so eventually all of our data has to be converted to numbers in order to do math with that data. We need numbers, right? So sometimes when they are giving you how the data is collected, basically, you kind of have to break down the process in which they collected that data to see how did the participants provide the data. And in this case, the participants provided the data in the form of words. So be real careful with that. That one can be kind of tricky because nominal is sometimes called nose counting or frequency counting, where it's just about working smarter, not harder. And instead of writing down Aveeno, Johnson & Johnson, Up and Up over and over and over each time someone responds with that answer, like writing it on your clipboard or your data sheet or whatever, you would just write down each of these one time and then do a tally. So you might have Johnson & Johnson, Aveeno, and Up and Up on your clipboard. And so when you ask Joe, hey Joe, which lotion did you like the best? And Joe says Johnson & Johnson. Instead of writing that out each time, you just do a tally. So the words are being converted to numbers, but what we need to consider here is how did the participant give the data? And in this case, it was in the form of words. Okay, so we also are looking to see if this is a hypothesis of difference or association. Again, this is a tricky one. There's no clear groups. It's just one group. But what we actually have are 3 conditions. So Johnson & Johnson, Aveeno, and Up and Up we would consider conditions. And we want to know the difference in preference between them. So this is going to be a hypothesis of difference. We're not looking to see if Johnson & Johnson is associated with Aveeno or Aveeno is associated with Up and Up because that really wouldn't make any sense. I just thought of this. Another way to identify that this is a hypothesis of difference in this case is that there are going to be 3 conditions. If it was a hypothesis of association, we would just be looking to correlate two variables. So here we have 3 different types of lotion, and so it's not, this hypothesis is not interested in associating 2 things because there are 3 things. Okay, and then 7, a sports psychologist decides to study the effects of mental imagery. And so mental imagery here is being operationally defined as visualizing each golf shot. And relaxation techniques, so deep breathing, is how they're going to operationally define relaxation techniques. And so they're going to look at the effects of those 2 things on improving golf swing. So if I want to if I want to isolate the hypothesis here, I could do that quickly. And then I could look for my IVs and DVs, remembering that the IV is the manipulation and the DV is the thing that we are measuring. So it says students in a beginning golf class are randomly assigned to conditions. So conditions, again, is going to be a keyword for a hypothesis of difference. So that just jumps right out at me. So I'm going to go ahead and highlight it so I remember it for later. Highlighter's dying on me. Okay, so assigned to conditions and receive treatment or not over the course of a semester. At the end of the course, a golf pro from a local country club assigned a score. Hold up. A score. Okay, that makes me think interval. I got to double check, but that makes me think interval. A golf pro from a local country club assigned a score to each student based on their golf swing. Okay, so it looks like here we have score, and that is how they are measuring a golf swing. So I know that what's being measured is the golf swing. So I'm going to put that as my DV because my dependent variable is what's being measured. And it's being measured by a score given to them from a golf pro. So I know scores are interval. And in terms of the hypothesis, again, we do have those conditions. So it looks like some people get the relaxation technique or are told to do that, and other people are not. And then there are also people that are told to do mental imagery and people that are told to not. So here, it looks like we actually have a hypothesis of difference with 2 IVs. So the 2 IVs are mental imagery in the form of visualizing your golf shots, and the deep breathing or the relaxation techniques. So here we actually have 2 IVs. So I'm going to show you how we draw that out visually. And you're going to be doing this in your near future when we get to ANOVAs and factorial ANOVAs. But here we have the IV of relaxation and the 2 levels of it. So no relaxation and relaxation. Here I'll just write deep breathing so we have kind of that reference, but this normally is not there. It can be. And then we have visualization for the mental imagery and no mental imagery. So then what we would do inside of these squares is put the means of the DV. So we would take the scores that were assigned to each individual that was in the no imagery and no relaxation group, and we would put their score here. Let's say their scores out of 1 out of 10. 10 is your Tiger Woods, and 1 is your mean, Professor Fell, who's never golfed a day in your life. So if you took the mean for everyone that was in the no imagery, no relaxation group, let's say that it was a 3. Okay, so pretty bad. And then we have the group that was in the imagery, so they did their visualization, but no relaxation. So let's say that they did a little better with the 5. And then no imagery and relaxation, also a 5. And then the group that was in imagery and relaxation, they did the best with a mean score of 8. Okay, so you're going to be seeing this in your future. It's called a contingency table, or you can just call it a block of cells. There's a bunch of different names for it, but we'll be talking about that soon. Anyways, it does visually represent our 2 variables here. Also, that we have 4 groups. And so that's a key that we have that hypothesis of difference because we look for the differences between all of our groups here. And so our last thing to do is figure out if this is assigned or manipulated. And since we are telling people to either do imagery or not and do relaxation or not, we are manipulating that. Okay? And that is all for this worksheet.